my dear students. Hopefully all of you are well. Alhamdulillah, I am also. This is Ghulam Mustafa, lecturer, Department of Mathematics, Milestone College. This is our second revision class of exercise 2. Follow this lecture attentively. Here see that I have written a CQ where set A, set C, set B and relation R are given. By using this system, we have to solve this CQ. Now, first one, express the set B in tabular method. Express the set B in tabular method. So, given B set where x elements of natural number such that x square is greater than 15 and x cube is less than 200. So, by using this internal condition, we have to solve the elements of B. We know the natural number set are all positive integer value. All positive integer. That means 1, 2, 3, 4, 5, ... up to. Okay. Those natural number whose are applicable for these two condition, then those value are elements of B. Okay. So, see that two condition, x square is greater than 15 and next condition x cube is less than 200. So, if here see that if x equals to 1, okay, by using this natural number value, if x equal to 1, x square is greater than 15, that means 1 square 1 is greater than 15, not acceptable because 1 is not greater than 15. Then if use 2, x equal to 2, then 2 square, that means 4 is greater than 15, 4 is not greater than 15, so this is not acceptable. Then 4, 3 square 9, 9 is not greater than 15, so not acceptable. 4 square 16, that means if x equal to 4, then 16 is greater than 15, this is acceptable. And x cube, that means 4 cube, 4 cube 64, 64 is less than 200, this is also acceptable. Again, if x equal to 5, then 5 square, that means 25 is greater than 15, it's acceptable. And 5 cube 125 less than 200, so this is also valid. If x equal to 6, see that if x equal to 6 square, that means 36 is greater than 15, true. And if 6 cube, that means 216 is not less than 200. So, acceptable value are 4 and 5. That means the elements of B equal 4 and 5. This is answer. Okay. Next 2. Okay, second one, let's see that 2 question. Express R in tabular method and find its dominant range. Express R, a relation R given x, y pair elements, x elements of A where x elements of A and y elements of A. The following condition is y equal x plus 1. We have to find at first the pair elements of R and then find domain and range. Okay. Now, given set A equal 1, 2 and 3 and relation R equal x, y such that x elements of A, y elements of A and condition y minus y equal x plus 1, y equal x plus 1. Okay. Now, following this condition, here see that x elements of A and y elements of A. That means following this condition, if we put this condition value of x, that means elements of A elements of A, then we find the value of y. Okay. Then see that condition is condition y equal x plus 1. Now for all value of x, that means x elements of a. Now for all value of x, that is elements of a, find out the value of y. Determine the value of y. Determine the value of y by a table. Okay, draw the table where first one is x and second one is y. So the elements of a 1 2 3, that means we need 3 box. So for 1, for x equal to 1, see that 1 plus 1, that means 2. For x equal to 2, 2 plus 1, that means 3. For x equal to 3, 3 plus 1, that means 4. X equal to 3, 4. But here see the x elements of a, that means 1 2 3 elements of a, and y have 2 elements of a, because in this condition y elements of a. So 2 elements of a, 3 elements of a, but 4 not elements of a. That means 4 not elements of a. Okay, therefore the fair elements or fair set not exist in R. That means, so fair elements of 3 and 4 not in R. That means the value or the elements of R 1 2 and 2 3, 1 2 comma 2 and 2 comma 3. We know that the in fair elements, first elements is domain and second elements called range. That means dom R, domain, that means dom R equal 1 comma 2, 1 comma 2, and range R equal 2 comma 3, 2 comma 3. This is answer. We have to identify domain and range. So domain of R 1 comma 2 and range of R 2 comma 3. Okay, then C. See that prove that A subtraction B union C equal to A subtraction of B intersection of A subtraction of C. Now we need the all elements of A, B and C. So here given A, but from B, from A we get the elements of B 4 5 and C, here C are given 3 4 and 5. So given A equal 1 2 3 and B, from A B we get 4 and 5, 4 and 5. Then C 3 5 and 6. Okay, so left hand side A subtraction of B union C. So you have to find at first B union C. B union C is B, that means 4 5, union C 3 5 and 6. Union means common and uncommon elements of this two set. So 4 3 4 5 and 6, 3 4 5 and 6. This is B union C. Okay, now left hand side A subtraction B union C. Left hand side equal A subtraction of B union C. That means the set of A 1 2 and 3, 1 2 and 3. Okay, subtraction, that means this B union C 3 4 5 and 6. So 1 2 3 subtraction 3 4 5 6. So here only 3 subtract. So 1 2, not this part 1 and 2. So 3 and 3 vanish. So we got 1 and 2. So left hand side 1 and 2. then we have to identify right hand side. That means from at first we have to identify the A subtraction B and A subtraction of C. Now A subtraction of B equal the elements of A 1 2 3, 1 2 and 3 subtraction, that means minus B 2 4 5, 4 and 5. Therefore 4 and 5, that means 4 and 5 not here elements of A, that means so all elements are A subtraction of B. Okay, next A subtraction of C, A subtraction of C. Left hand side elements is 1 and 2. Now A subtraction of C, A C, that means A elements 1 2 and 3 and subtraction C elements 3 5 and 6 subtraction we can here. So 3 and 3 finish, so 1 and 2 only, 1 and 2 only. Now right hand side here see that A subtraction B intersection of A subtraction C. So right hand side equal A subtraction of B intersection of A subtraction of C. That means A subtraction of B we get 1 2 and 3, 1 2 and 3 intersection A subtraction of C we get 1 and 2, 1 and 2 set. So for those two set the common part is 1 and 2, 1 and 2 intersection, that means common from both two set, so we get 1 and 2, that means left hand side and right hand side equal. So you can write as therefore left hand side equal right hand side. Proved. I hope everybody clear this CQ. Now next creative. Here the given scheme are set A, function f of x and relation R. By using this scheme we have to solve A, B and C. Okay, now first one A. Question number A, here see that what is the value of f of half. That means to find the value of f of half we need to use the function f of x. If we replace half by x then we will get our solution. Now given f of x equal 1 divided by x minus 1. So replacing x by half we can get 1 divided by half minus 1. That means 1 divided by half minus 1, that means minus half. So if we by simple calculation we can get it minus 2 by 1 reciprocal. Okay, then the answer is minus 2. So the answer is minus 2. Now B, according to scheme find range of R. That means we have to use to identify the range R this. Now B, you see that to solve B the range R given from scheme is x y, that means pair elements belongs to x elements of A, x elements of A and y elements of A, it would be A, x elements of A and y elements of A and y minus 2x minus 1 equals 0. This is the condition to find the range. Okay, now we need to the set of A to find the range from this relation. So here we have to identify the elements of A. So A equals to given A equal x belongs to z, that means integer number, such that 1 less than equal x square less than equal 7. See that by this condition the set of A is x belongs to z. We know the set of integer number all positive and negative value. That means suppose minus 5, minus 4, minus 3, -2, -1, 0, 1, 2, 3, 4, just like that. Okay, so if we use the integer elements from in this condition, the applicable value is elements of A. Here see that if we use 1, so 1 is square, that means 1, that is equal 1. So the limit is 1 less than equal x square and less than equal 7. Okay, that means x square is greater than equal 1 and x square is less than equal 7. This is the condition. So if we use the value from integer set, so if we use 1, that means 1 square is applicable, so 1 applicable. If we use -1, -1 square also 1, that means -1 acceptable. If we use -2, okay, so -2 is the elements of integer set, so -2 square, that means 4, so 4 less than equal 7, that means -2 acceptable. Then +2, 2 square 4 plus 4, that means less than equal 7, that means 2 acceptable. But others the value, suppose use -3, 3 square, that means 9, so 9 not less than equal 7. Okay, that means the elements of A 1, -1, -2 and 2. Okay, here the relation R equal x y such that x belongs to A, y belongs to A, y elements of A, and the following condition or equation 2x minus 1 equal 0, closing by second bracket. Now the condition is condition y minus 2x minus 1 equal 0. We can write it as y equal 2x plus 1. So here see that in this relation x elements of A and y elements of A, that means if we use the elements of A in this condition, then we have to find for different value of x, we have to find the value of y. Okay, now draw a box as like that to finding the elements of x and y. Here elements of fair set of here elements of A 1, 2, 3, 4. So we need box 4. 1, 2, 3, 4. This is for x and this is for y. Okay, so for x equal to 1, here see that 2 into 1 plus 1, that means 3, y 3. For x equal to minus 1, so y equal to x equal to minus 1, minus 2 plus 1, that means minus 1. For x equal to minus 2, we get minus 2 into 2, that means minus 4 plus 1, so minus 3. For x equal to 2, that means 4 plus 1, 5. X equal to 2, the elements of 5. But in this relation here see that says that x belongs to y, x elements of y. So this element x 1 minus 1 minus 2 2, this is elements of y. Here see that this is elements of A, and the value of y 3 not elements of A, and minus 3 not elements of A, 5 not elements of A. So this is not elements of A, therefore the fair set of this not acceptable for the relation R. Okay, so we can write 3 minus 3 and 5 not elements of A, therefore the pair elements of 1 3 and minus 2 minus 3 and 2 5 not elements of R. So the elements of R only these pair elements. So R equal minus 1 and minus 1. Therefore the range and domain are same. So domain or range of R minus 1 and domain minus 1 and range also minus 1. Therefore dome of R. Therefore we can write dome of R or range of R. According to question we have to identify range of R. So you can write range R equal minus 1, second bracket minus 1. This is answer. I hope everybody clear. Now next one, C. Show that f of m minus f of n is not equal right hand side. That means To prove this, we have to use this system, the function of f of x. Okay, so given given f of x equal 1 x minus 1. So left hand side we need f of m and f of n. So function of m replaced by x equal 1 by m minus 1. Again we need function of f of n. See that we need function of f of n. So f of n equal replaced by x by n. So we can get 1 by n minus 1. Okay. Now from right hand side, see that if we replace x by in right hand side mn divided by n minus m, we can get again f of mn divided by n minus m. By calculation, see that what happened, 1 divided by replace x by mn divided by n minus m. So mn in x replaced by this value, so n minus m, then minus 1. By calculating we get 1, then LCM in denominator fraction, so LCM will be n minus m, then n minus m same, that mn minus 1 into denominator, so n minus 1 into n, that means minus n, minus m into minus 1, that means plus m. So by reciprocal we can get this n minus m divided by mn minus n plus m. This is the value of f of mn divided by n minus m of right hand side. Now we see that the value of left hand side, f of m minus f of n. Okay, so here in here we write this part. Okay, again f of m minus f of n. Okay, see that f of m, that means 1 divided by m minus n, 1 divided by m minus n. Okay, now minus 1 divided by n minus m, sorry, n minus 1, okay, by calculation LCM m minus 1 into n minus 1, so LCM will be m minus 1 and n minus 1. Now m minus 1, so LCM will be, so the multiplier n minus 1 into 1, that means n minus 1, then minus n minus 1 and n minus 1 same, so the rest part are m minus 1 into 1 and minus 1, so we can write minus m plus 1 because multiply by minus 1 sign here. Okay, now by simple calculation we can get m minus 1 into n minus 1 and rest part are here, plus 1 and minus 1 vanish, that means n minus m. But see that this part and this part are not equal, so we can say that left hand side and right hand side are not equal, so we can say that therefore this is left hand side not equal right hand side, proved. I hope everybody clear. Now MCQ part. Here see that first MCQ, if the set A equal elements 0, then what is the value of P of A? Simple. Here elements of A is only 0, that means only one elements. So power set of A will be 0 and empty. Okay, then 2. Which one is the solution set of this equation? Solution set. That means the equation is x square equal root 5x. So we can write x square minus root 5x equal 0. So we can get common x, that means x minus root 5 equal 0. Here see that x and x minus root 5, here this is by 2 factor. Okay, arranged by 2 factors. So we can say first factor, either first factor equals 0 or second factor equals 0. So you can say x equals 0 or x minus root 5 equals 0. That means x equal root 5. So the solution of x is 0 and root 5. So we can write as a solution set x equal 0 and root 5. This is the solution set of this equation. Okay. Now 3. The set A 3 elements and the set B 2 elements. How many elements of P of A subtraction of B? So at first we need to subtraction B from A. So here see that B from a subtract, if we subtract B from A, B and B vanish, C and C vanish. That means only A exists. That means A subtraction of B equal only single elements A. So now P of A subtraction of B equal only 2 elements A and empty set. A and empty set. That means 2 elements power set of A subtraction B. 3 complete. Now 4. How many elements in power set of empty? How many elements power set of empty? Only 1 element. This is the power set of this. Empty is the power set of empty set. So in empty set power set is only 1 elements. Clear? That means this is answer only 1 elements. Now 5. If f of y equal, the function f of y equal 3y plus 1 and y minus 1, what is the value of f of minus 1? Simple, we replace y by minus 1. So see that the answer is, so replace f of y by minus 1 equal 3 into minus 1 plus 1 and then minus 1 in denominator. Okay, y replaced by minus 1. So in denominator minus 2 and numerator 3 into minus 1, that means minus 3 plus 1, so minus 2. So answer is only 1. If you face any difficulty, you may ask me question anytime. I am available online. Before next class, submit HW, Comilla board 19 and Chattogram board 17, only CQ part.